everybody, it's Mr. Blumgren here. You know, I felt like I was really missing out when I put together your Shoebox of Physics final assignment for this semester. So I decided, you know what, might as well put one together and show you guys some yo-yo physics and kind of understand how a yo-yo works. So the main question that I'm sure a lot of you guys were asking, what causes rotation? What physically causes rotation? What are some factors that cause rotation? How do these factors affect how quickly the yo-yo spins? Things like that. So let's dive right in. So a traditional yo-yo that you might see at a store might look like this, kind of a narrow yo-yo with a small gap. Probably something that would just go up and down mainly. But yo-yos have evolved over the time, and now you get yo-yos that look like this. They're aluminum, have a very wide gap with a very wide bearing inside them. And this allows for very high performance yo-yo trick play. After breaking this yo-yo apart, you will see a stainless steel ball bearing on the very end of it with the string around it. You also see that red friction pad there. Now the friction pad allows the string to catch the yo-yo to catch the string, thus bringing it back up to your hand. And that ball bearing right there, it actually spins very, very fast. I grabbed another yo-yo here. You can actually see the ball bearings inside that, and that allows for very low friction, which causes it to spin very fast when the yo-yo spins around it. So you can actually see it spin pretty fast just by flicking it with the finger. You can see it spins for quite a long time, so that's what causes it to be able to sleep, as they call it, at the very bottom of the yo-yo. What we're going to do today is represent this ball bearing and this axle with this bowl and this circular piece of tape that I covered with paper. And we're going to kind of dive into the physics of why and how this yo-yo spins. So anything that spins needs to have what is known as an axis of rotation, and that's typically going to be the very center of mass of the spinning object. So anything that spins must have some sort of force to cause it to spin. In particular, for a yo-yo, this force is going to be force tension provided by the string around the very gap of the yo-yo, and that's always going to be parallel to the direction of the string. So if the string was being pulled this way, the force will be pulled this way. I'm just going to put that there, and that's going to be right here, tangent to the ball bearing. Now the next thing that a yo-yo needs to have in order to spin, or anything in general, is going to be called a lever arm distance. That's the distance between the axis of rotation and the force that's providing it to spin in some direction. You can see that the force is always perpendicular to the lever arm distance that causes it to spin. You can kind of see here that if I were to pull this string, the yo-yo is going to spin in a counterclockwise direction, just by the way the force is positioned relative to the axis of rotation. And there you have it. All you need to get an object to spin or rotate is some sort of force. You need an axis of rotation for it to spin around. You also need a lever arm distance for the force being away from the axis of rotation. We now have a concept called torque, and this is what allows objects to spin and rotate. And actually it's going to be counterclockwise because the force is counterclockwise from the lever arm for this one. So there we have it, torque. So it just so happens that the amount the rotating object will accelerate is directly proportional to if you take the lever arm distance and you multiply it by the force that's perpendicular to the lever arm distance. If you multiply these both together, you're going to end up with a constant known as torque. And this torque, if I'm going to put this down here, this torque is related to the acceleration of the rotating object. The more torque that the object's undergoing, the faster it will accelerate in a clockwise or counterclockwise direction. And we may be wondering, wait a second, isn't there another force acting on this yo-yo? Well, of course there is. There's the force of gravity, which acts on all things with mass, and that's going to act directly on the axis of rotation because it also acts on the center of mass of all objects. So let's look at just the force of gravity here. You can see that it's directly acting on the axis of rotation, and you might ask yourself, does this cause the yo-yo to rotate? Well, we can see that there's a force on here, there's an axis of rotation, but what's missing? What's missing is the lever arm distance. There's no distance from the axis of rotation, the force is. So this would result in no torque acting just by the force of gravity. So what that's saying, if I were to just drop this yo-yo with no string, right, that's not going to start spinning because there's no lever arm from the force. Now, if you've ever played with a yo-yo before, you might come into some issues. Let's say you're just to drop it like this. Usually you're not able to get it all the way back up to your hand. There's kind of a distance where it stops, and you cannot fully reach the top of your hand again. Now, that's because we weren't able to acquire enough torque. Remember that torque is related to how fast the yo-yo accelerates, thus how fast the top speed of the rotation will be. There was not enough speed, so there was not enough speed to get it back up to the top of the string. If you've thrown it down like this a few times and you're not able to get it back up to your hand, you soon realize that you can start to throw the yo-yo down and it spins sufficiently enough where you can pull it up and it reaches right back up to your hand. And this is because there was not enough torque. Now, an easy way to increase the torque or the acceleration of the spinning object is to increase your force. And by throwing the yo-yo down, we were able to increase the force of tension, thus creating enough force to get enough torque to accelerate the yo-yo fast enough to get to spin fast enough to bring it back up to your hand with the flick of the wrist. So I'm excited to see your shoebox of physics examples of objects that you use every day and kind of connect that with physics that you learned this year for your shoebox of physics final. I'm excited to see it. Bye. All right, so I think I've been talking in circles enough. So make sure to subscribe because next year it's going to be planes.